Carbon dioxide often takes center stage when it comes to climate change and global warming discussions. But what if I told you that there's a gas that is 1,000 times more dangerous than CO2? Meet sulfur hexafluoride, or in short, SF6, a greenhouse gas that is as fascinating as it is dangerous. For greenhouse gases, we measure how damaging they are by this GWP, global warming potential. 1 kilogram of CO2 is equivalent to 1 GWP. Methane is 28 GWP. You know how they're making a big issue about cows farting and those kind of stuff?
I'm going to talk about cow flatulence, but...
which is an issue, I just want to say.
An issue.
Yeah, because 1 kilogram of methane is 28 kilograms of CO2. But this SF6 is the most potent greenhouse gas known to science, with a global warming potential of over 23,500.
It's over 9,000!
Let that sink in. In simpler terms, this means that it takes 23,500 kilograms of CO2 to match the performance of 1 kilogram of SF6. And here we are talking about how to reduce methane and CO2. Yeah, like how to pay some extra money to offset your flight emissions. So what actually is this SF6 and where is it used for? SF6 is a synthetic gas made out of 1 sulfur atom and 6 fluoride atoms. SF6 has remarkable properties, which are non-flammability, chemical stability, indestructible, and excellent electrical insulation, making it indispensable in electrical equipment like circuit breakers and transformers. I meant this transformer. SF6 is best when it comes to electrical insulation. Its density ensures effective containment and performance in electrical systems. Nothing even comes close to SF6 when we are talking about breaking and dousing electrical arcs so consistently, reliably, and in a safe manner. The electrical industry has perfectly lobbied its way to make SF6 invisible to the climate change conversation in your local parliament. Also, we mentioned about synthetic gas. Synthetic gas means that it is man-made. It does not occur naturally. Remind you of something else that is man-made and does not occur naturally, and therefore cannot decompose naturally as well? SF6's unique molecular structure and its nearly indestructible properties means that it does not break down in the atmosphere easily and can last for up to 3,200 years. But wait, SF6 is super heavy, right? Like highly dense, more than 5 times heavier than regular air. This means that SF6 doesn't easily mix into the upper atmosphere. Instead, it tends to accumulate at the lower altitudes, closer to the ground. But then, how does it trap heat when it's just close to the ground? Don't you have to be like high up in the air to trap heat and have the greenhouse effect? Because of its density, SF6 behaves differently from lighter gases like CO2 and methane. It tends to stay near to the surface rather than dispersing evenly into the upper atmosphere. Its presence in the lower atmosphere contributes significantly to localized warming effects. Even though it stays low in the atmosphere, the amount of heat it traps over time adds up dramatically, making it a critical greenhouse gas. Like, do you now know why it is hotter at lower ground and cooler in the mountains? Does that solve your 10th grade science dilemma now? To combat its environmental impact, industries are now seeking alternatives. New technologies like vacuum and air-insulated circuit breakers are emerging as SF6-free solutions. Some companies have even come up with SF6 alternatives. First up, we have a product from GE and it's called the C4. Well, they later rebranded into G-Cube because C4 sounds very dangerous and explosive. The composition is a 2,3,3,3 tetrafluoro2-trifluoromethyl propyl While it is not as dangerous as an SF6, it is still high on the global warming potential with a rating of 2,100, and it lasts in the atmosphere for 30 years. This is mainly because it still has the F gas inside of its composition, like CFN. Next, we have a product from ABB called the Air Plus. It's like Air but Plus, but a premium Air. iPhone Pro Max, Air Plus. The composition is a 1,1,1,3,4,4,4 heptafluoro3-trifluoromethylbutyne 2,1-C5. Previously it was a C4, now we have a C5, an upgrade. While they market the Air Plus product as a SF6 alternative, the composition still has the F gas inside. The global warming potential is now less than 1 and the atmospheric dwell time is 0.04 years, meaning that it breaks down pretty quickly in the atmosphere. The main problem with this is the boiling point, meaning that it's only a gas state once it is above 27 degrees Celsius. Below that, it is not gas, and when it's not gas, it's not that usable. This causes issues like you need to have heating and you cannot be used in cold climates. And last, we have a company, Siemens, and they came up with clean air. Wow, so original. And then they didn't like it as much. They call it synthetic air, and then they call it dry air. You can't really decide which one is more catchy or more marketable yet. The composition is just oxygen and nitrogen. And if you have enough general knowledge, that is the main composition of our atmosphere itself. Nitrogen and oxygen. It has a global warming potential of 0 because it is basically the atmosphere. Atmospheric dwell time of not applicable because it is the atmosphere. But what makes it so good? Well, it's basically air that is dry and zero moisture and is highly compressed. And they figured out that that itself is enough to douse electrical arcs. No issue with the boiling point temperature as well. The main drawback of this clean air is that you cannot be refurbishing old assets onto this. You must build a new chamber that can withstand higher pressure to handle this clean air. Who knew that it was this hard to adopt cleanliness? And of all the solutions, this is the first one without any F-gas in them. So yeah, there is hope before SF6 become the new plastic. Because it is gonna stay around for about 3,000 years.
You're watching the Funsi channel.